In this video, we will continue to verify trig identities. If we look at number 1, I can see that the right side is much more simple than the left. That tells me I want to try to simplify the left side. Since this is trying to equal a value of 1, that means I really just want to try to simplify the left side. Please pause the video and try to do number 1 on your own. In number 1, I can see that I don't have any cofunction or negative angles, nothing squared, so there's no Pythagorean identities to perform. I do not have any fractions. I do not have even more than one term to factor out, so we need to change each of these into terms of sine and cosine. Sine already is, but secant, if I use the reciprocal identity, is 1 over cosine. And cotangent, if I use the quotient identity, is cosine over sine. If I now look at these and multiply all three of the fractions straight across, I have sine of x times cosine of x divided by cosine of x times sine of x. I notice that since there's multiplication in the numerator and in the denominator, the sines that are in common can cancel out, and the cosines that are in common can cancel out. And anything divided by itself is a value of 1. And so therefore, 1 equals 1, which is what we are trying to get. If you now look at number 2, you will again notice that the right side is more simple. Please pause the video and complete number 2, then verify with the video. So in number 2, again, if I go through my steps, I notice that I need to change everything in terms of sine and cosine. The numerator cosine is already in those terms. Sine is as well, but cotangent, I again want to use the quotient identity to change to cosine squared over sine squared. I'm squaring them because, again, the cotangent was squared. If I simplify that denominator, I notice that this sign can cancel with one of the signs in that denominator. And so my new denominator is just cosine squared over sine. Whenever we have a fraction within a fraction, we want to multiply the denominator and the numerator by the reciprocal of the denominator. Here that reciprocal is sine divided by cosine squared. Again, the point behind this is to completely cancel out that first denominator. What you then have to do is multiply the numerator so that you can simplify. Here, I can see that this cosine that was in the numerator originally cancels with one of the cosines that was in the reciprocal of my denominator. That leaves me with just sine divided by cosine, and by the quotient identity, sine divided by cosine is the same thing as tangent, which again is what we were trying to get. Please now look at number 3. Pause the video. When you are done, check your answer with the video. In number 3, I'm noticing that both of these terms on the left are 1 over. That means I could use the reciprocal identity to change 1 over secant squared to cosine squared, and 1 over cosecant squared to sine squared. Then I notice that cosine squared plus sine squared is a Pythagorean identity, which gives me the value of 1 I was trying to get. Done. Please now again pause the video and try to do number 4. In number 4, I'm noticing I have 2 terms. In those 2 terms, both of them have a GCF of cosine squared. I want to factor out that GCF, and that's going to give me cosine squared times, again, if you take the original terms and divide them by your GCF, you'll see what goes inside the parentheses. Here, cosine divided by cosine is a value of 1. And those cosines cancel out to leave me with the tangent squared. Next, I notice that 1 plus tangent squared is one of my Pythagorean identities. That's the same thing as secant squared. Next, I notice that both cosine and secant are reciprocal of each other. And so if I change one of these to its reciprocal identity, when I multiply straight across, I get cosine squared divided by itself. And anything divided by itself is a value of 1. Let's now take a look at number 5 together. In number 5, again, I'm going to notice that the left side is what I want to simplify. Going down my list, there really isn't anything that I can do except for something with the fractions. I do have a fraction here, and right now it is already one fraction, but remember, the only thing that you can do is not always the most simple when you're verifying. What I want to do first is I want to make 2 fractions, each with that denominator of sine squared. When I do this, there's not going to be anything I can do with the first fraction, but in the second fraction, the sign that's in the numerator can cancel with one of the signs in the denominator. This gives me tan x divided by sine squared x minus just cosine x over now just sine x. Next, remember, a lot of the times you're trying to get things to be one fraction. Well, here, I just made this so that they didn't have a common denominator. So we don't want to put this back into what we originally had. So again, if you are lost on things to do, you can always try to change things in terms of sine and cosine. And so tangent here is the only thing that is not in terms of sine and cosine. So let's change that with the quotient property, doing sine divided by cosine, still over the sine squared, and still minus our cosine over sine. Now remember, to get rid of a fraction within a fraction, you want to take the reciprocal of the denominator. Again, that completely gets rid of your denominator. And here when I multiply the numerator, the sign in the numerator can cancel with one of the signs in that denominator. And so that's going to give me 1 over sine times cosine minus cosine over sine. Again, thinking about things that we might want to do. Well, remember, right now I have 2 terms and I eventually want to be just 1 term. And so now that we've done a little bit of manipulating, let's try to get a different common denominator of sine times cosine. That means I need to multiply the second fraction times a cosine. Now I have 1 over sine x cosine x minus cosine squared over sine x cosine x. When I make one fraction, I notice that my numerator now is one of our Pythagorean identities. 1 minus cosine squared is the same thing as sine squared. And since I have a sign in both the numerator and the denominator, again, I can cancel one sign with one sign. This gives me sine over cosine, which by the quotient identity is the same thing as the tangent we were trying to get. So what you should notice in this problem is that you aren't always able to follow those steps for simplifying. Sometimes you have to make things a little bit more unsimple to be able to get it to what you want in the end. Please now take a look at number 6. Pause the video, and when you are done, verify with the video. In number 6, I'm again noticing a GCF in these two terms. So if I factor out that GCF of sine squared, I'm going to be left with a 1 plus tangent squared. Again, to get the 1 and the tangent squared, I'm just dividing each of the original terms by my GCF. Next thing I notice is that 1 plus tangent squared is one of our Pythagorean identities. That's the same thing as secant squared. Now if I look at this, the only thing I can do is change everything in terms of sine and cosine. Sine squared already is, but secant squared is the reciprocal with 1 over cosine squared. If I multiply these fractions straight across, I'm going to get sine squared over cosine squared, which happens to be tangent squared by one of the quotient identities. That's very close to what I want, but again, you must remember you're not always simplifying. In this problem, I actually wanted the Pythagorean identity that tangent squared is equal to, and that's secant squared minus 1. Please now take a look at number 7. Pause the video. When you're done, check your answers. In number 7, I'm again noticing that I have two terms that I need to make one. The problem is you can't just separate this 1 with one of these square terms to use a Pythagorean identity. So really your only option here is to make everything in terms of sine and cosine. So the 1 we're not going to do anything with, but the secant squared I'll make 1 over cosine squared. It's reciprocal. And when I multiply that times sine squared, I have sine squared over cosine squared. If I use the quotient identity, that's the same thing as tangent squared. And then 1 plus tangent squared is another Pythagorean identity giving me secant squared, which is what we wanted. Please now take a look at number 8 and decide what you might want to do. In number 8, because I see the 1 plus in a denominator, I might be thinking about using the conjugate. But I'm going to tell you, if you were to multiply the numerator and the denominator by 1 minus cotangent of x, you are not going to be left with a Pythagorean identity, and pretty much the only time you want to use the conjugate is when you would multiply and be left with a Pythagorean identity. Since we don't have that here, really the only thing we can do is change things in terms of sine and cosine. If that helps you, please again pause the video and try to do number 8. Okay, since we're going to do things in terms of sine and cosine, I want to change the tangent to sine divided by cosine, and the cotangent to cosine divided by sine. The next thing that I'm noticing is that again I have fractions and fractions within a fraction. Before you can get rid of the fraction within a fraction, there needs to only be one fraction in the numerator and one fraction in the denominator. That means I need to make these ones have a common denominator so that I can have one fraction. Well, here I want to have that common denominator to be cosine. So the way I get a value of 1 is cosine divided by cosine. Down here, I want to have a denominator of sine. So I'm going to change 1 to sine divided by sine. Now, if I actually combine the numerator fractions and combine the denominator fractions, I have cosine plus sine divided by cosine, and I have sine plus cosine divided by sine. At this point, we can get rid of the fraction within a fraction. Remember, that means you're going to multiply top and bottom, the numerator and the denominator, by the reciprocal of your denominator. Here again, the point is to completely get rid of your denominator. What also happens is that because addition, order doesn't matter, the sine plus cosine cancels with the cosine plus sine. This leaves me with just the sine in the numerator and the cosine in the denominator. And that is exactly what we wanted to get. Please now complete your homework worksheet for tonight.